Now here we're going to look at the proof of the quotient rule. Now you'll see that this is very similar to the proof of the product rule, but with just a little bit more algebra involved. So we want to start out by looking at the derivative of f over g. So we want to evaluate. And we're going to go back to our limit definition for that. Alright, so here we have our limit definition for the derivative of f over g. So you see right here we have a large f of x plus delta x right here, with the large f of x being f over g. And here's our large, just f of x. And now what we're going to do is we're going to clean up this numerator by finding a common denominator, or cross multiplying. So we're just going to cross multiply like this, and then multiply those denominators together. And what we're going to get is this. Alright, so here we have simplified the numerator by cross multiplying or finding a common denominator. Notice that the numerator is this piece. So we've got the large fraction right here. That's right there. All of this is in the numerator. And then the delta x is our denominator. So now what we're going to do is we're going to do a little simplification. We're going to pull the g of x plus delta x times g of x out, sort of using a rule like this. We're looking at this as a over b divided by c. So the a is this, the b is the g times g, and the c is the delta x. We're going to write this as 1 over b times a over c. Alright? You see, because the 1 over b you can think of as just being a number and multiplying it into the numerator, and you get a over b. Alright, so we're going to pull this b here out and write it as 1 over b in front. And the b is our g times g. So, here we go. So we'll move over here, and then we get and now I'm going to save myself a little bit of writing by incorporating one step right here. You'll see what I do. Alright, so what we have here, let me just clean this up a little bit right here. Alright, now you notice what we did is we rewrote this. So there's our 1 over g times g right here pulled out. Alright, this term right here has now been pulled out front. Now we have then left this part right here, which is here and here. And I added in, I did a math trick, added in and subtracted back out a term, and you'll see why in a second, why we did that, and then to have our delta x here in the denominator. Alright, so now we're going to do some more algebra. So we're going to write this as and now what we're going to do is we're going to combine terms like this. We're going to combine these two terms together, and we're going to factor out a g of x, and then we're going to combine these two terms here together and factor out an f of x, and then we're going to split the fraction apart right at this plus symbol right here and divide each side by delta x. So let's see what we get. I see I have one error right up here. That term right there should be a minus. See, this minus right here comes from that minus right there. Okay. All right. Now we're just about finished, because we see as delta x is approaching 0, this term right here, this term is going to be approaching 1 over g squared. Because we can just put 0 in for the delta x right here, and we get g of x times g of x. Now over here, in here, this g of x, that stays g of x right there. That doesn't depend on delta x. This term right here is your derivative of f. That's f prime. So you see what you're getting is you're getting g of x times f prime of x. So we get g of x times f prime of x. And over here, this term is approaching f of x. Now this term right here, you notice that we have the g and the g of x plus delta x flipped. So this is going to be approaching negative g prime of x. You see, because g prime should normally be written in a limit as, it should be written as g of x plus delta x minus g of x over delta x. But you see what we have here in this piece, this is just this piece right here is the negative of this. And so this is approaching negative g prime. And so we end up with this. We end up with this approaching negative g prime. And now we have this negative makes that a minus. So we get minus f of x times g prime of x. And we have our quotient rule. Notice if we simplify this now a little bit, we can write this as, we've got g times f prime minus f times g prime. And then all of this is being divided by g squared of x. And that is exactly what our quotient rule up here is stating. And so we have now proven the quotient rule. And there you go. So all it was some algebra. We had to do that math trick where we added something in and subtracted it right back out. Then we did some more algebra, and we used the limit definitions for our derivatives here. And we ended up with our answer right down here. Okay, so that is the proof of the quotient rule.